Okay, this is the second video for EES, and on the first video we show basically the normal operation of the board. On this particular case, what we're going to do is we are going to, and we already noticed that signal, we have I have at 5 milliseconds per division. Keep in mind that this is all at 60 Hertz, not 50 as reported, but we can see that we have set up or a signal generator, just open it so that we see it, so that it goes from 10 to 0 volts, and then it goes back from 0 to 10 as a step function. I think the frequency is 300 millihertz, so we can see it up and down, and we basically have the same signals. We have TP7 on green. We're gonna have the AC input through the CT on purple, then or violet. On magenta we have the output, and the board right now it's inhibited. It's not until we turn it on, although SIG HI it's ready to fire. The board is not doing anything because it's inhibited. Alright, so let's go ahead and turn it on, Tony. There it is. So now a couple of things to notice. First, the output, the AC input stays at 244. The output, as expected, goes between 0 to 305. Those are the values that we obtain. With a resistive load, we can see our lamps going on or off, and that's a result of this signal generator going 10 to 0, 0, 10. So now, looking exclusively here, this is 100 milliseconds. I'm going to start going in. You notice that the current is high, the output is high. We never, this we can't see in details, but we're going to look at it in a close-up in a little bit, and that's SIG HI 0, SIG HI 10, 0, and then we have these transitions 10, 0, 0, 10. There's basically no over voltage condition. The board stays unlocked. Now the other thing I want to show here is, at this low frequency, again 60 Hertz stays for the reference, but we notice that the delay angle changes from 158 to 9.5, again once as reported by ESS. Now what I'm going to do is I'm going to start closing in and show that there's no biasing on TP7, the green channel, and now I have 10 millivolts. We see that there's no offset here, keeping in mind that we have a resistive load. So 0, 10, 0, 10. So the board never loses lock acquisition. It's always in control. We don't have an over voltage condition. There will be a couple of things to discuss on the phone, specifically the phasing and this, more importantly the biasing of this, which is probably a function of the delay angle. The last thing we want to do is just try to capture one of these transitions. So we're going to go for a single trigger. We're going to do it on channel 1. My setup is at 6.10, so that will probably work. Okay, there it is. So if I go for another one, again, this still producing it. Notice that there's no biasing. There's my 0. Do it again, and you notice that there's slight spikes here, but it's not. They're not conducting. The SCRs are off. They're not conducting. So this is the end of this second video.